I don't know how many people know this, but the moon is spiraling away from Earth an inch or two a year. How do we know? Well, Neil Armstrong put down mirrors on the surface of the moon when he landed and walked there back in 1969 in July. Now we take lasers on Earth. We know how fast light travels. You beam it to the moon, time the return signal. You have special detectors to catch that. And you do distance equals velocity times time. Is that right? Yeah. Distance equals velocity times time. And you get the distance to the moon. And you find out it's spiraling away. And it's been doing that ever since it formed billions of years ago. It's been spiraling. So the moon's getting smaller, slowly getting smaller. And it's getting smaller because the tides that it raises on Earth, these oceanic tides, actually are ahead of the moon in its orbit. Because Earth is spinning faster than the moon orbits us. So we're dragging the tides ahead of what the moon actually wants to do to the water. And that tidal bulge, being ahead of the moon, is actually flinging the moon into a higher orbit. The cost of that is that Earth's rotation rate is slowing down. We're turning into these sloshing tides on our oceanic shores. And we're slowing down, so every now and then we have to make it up with the leap second. There's been nearly 30 leap seconds introduced since the early 1970s, 27, 28 leap seconds since the early 1970s, when we were first able to determine that this was happening to the Earth and to the moon. It is a cosmic ballet choreographed by the forces of gravity.